Alright, so it looks like today, what's the today, the 26th? Today we're going to be solving equations with variables on both sides. And both sides means both sides of the equal sign. So, let's look at 5x plus 2 equals 2x plus 14. And I'm going to suggest out here that you always move I'm going to say move the smaller variable. A lot of times nobody knows, or not that nobody knows, sometimes people start these problems differently. They start by moving the variables to one side or moving the numbers to one side. It doesn't really matter which step you do. I like to move the variables first. And I like to move the smaller variable, because if you move the smaller variable, a lot of times it will eliminate a negative in front of the variable. It will also answer the question, I don't know which variable to move first. Well, if you give yourself a rule, like always move the smaller one first, it eliminates thinking. Okay? And the less you got to think, the easier things are. So if you just always move the smaller variable, the 2x is smaller than the 5x. So when we move it, we subtract 2x from each side, because that eliminates it from the right side. So we get 5x minus 2x, which is, we get a 3x plus 2, which is equal to 14. And once again, after the first step, it looks like the problem we did on the first day, right? So subtract 2 next. And 3x is going to equal 12. And then divide by 3. The 3's will cancel. And x is equal to 4. Alright, so let's try 7x or 7k plus 2 is equal to 4k minus 10. Again, remove the smaller, so I'm going to subtract 4k from each side. And 7k minus 4k, we get another 3k plus 2 equals negative 10. Gonna subtract 2 from each side. The 3k moves down, and 3k is equal to negative 12, and we can divide both sides by 3. And yep, looks like k is going to be equal to negative 4. Good. Then we will progress into equations with grouping symbols. So now we're going to kick it up a notch, and we got a 2 times a 5x minus 1 equal to a 3 times x plus 11. Now, we did those problems yesterday. We didn't have to do the distributed property twice in one problem, but here you're going to have to. So we're going to distribute this 2 on the left side. So we got 2 times 5x, which is 10x, and 2 times negative 1 is negative 2. And that's equal to, now we got to distribute the 3. So 3 times x, which is 3x. And we got 3 times 11, which is positive 33. And now, move the smaller variable. So subtract 3x from each side. So we get a 7x minus a 2 equal to a 33. And add 2 to each side. So our 7x equals 35. And then divide by 7. X is equal to 5. Have you noticed like the progression of the problems? Right? We did this day 1, and then we did this second half of day 1, and then we did this, you know what I mean, today. All they really keep doing is just adding one more little step to the beginning, right? Whether it's distributed property or combining like terms. The bottom line is you're always trying to make it look like a variable on one side and a number on the other side. You're just step by step shrinking the problem down so that you're eventually just left with a variable and a number. Let's do one more of those. Let's do a 7 times 4 minus a. And that's equal to a 3 times an a minus 4. Again, that's called double distributed property. So we got a 7 times a 4, which is a 28. And we got a 7 times a negative a, which is a negative 7a. Got a 3 times an a, which is a 3a. And a 3 times a negative 4, which is negative 12. So now we're going to move the smaller. And the negative sign in front of the 7a, that minus sign means the 7's negative. And if you move the smaller, okay, you're going to move the negative 7a. So you're going to add 7a to each side. So on the left-hand side, you have just a 28. And on the right-hand side, we get 10a minus 12. Now we can add 12 to each side. (28 plus 12) 40 equals 10a, and divide by 4. So 10 is equal to a. Good with that? Questions? Concerns? Comments? Yes, sir? Nice shirt, by the way. Yeah. Anybody else notice that? But nobody else said anything. He said, wouldn't you divide both sides by 10 instead of 4? But nobody said anything except one person in the whole class. Oh. That means you turn into robots. You just copying down whatever I put up there, right? You try to think it through when you're copying it down. Don't just write down whatever I write down. Sometimes I'm going to lie to you. And I'm going to see. What was the answer that I had up there? Yeah, it's not 10, is it?
It's 4.
Yeah, it's 4 equals A. See, I did that on purpose just to see who's really paying attention. I think I just got bored. Yeah, that's what happened. Yeah, I have A D D D D D D D D D D with a bunch of D's at the end. Yeah, I could be doing something and start thinking about something else, and the next thing I know, I have messed up what I'm doing so bad, and I don't even know where my brain is at. So, especially in class when I'm doing these problems, like I got about halfway through that problem, I think I started thinking about lunch or something like that, and I lost track. So I got to really concentrate on staying focused. It happens a lot to me, but oh well. I think a lot of people are like that. I mean, my wife will be talking about one thing, and in the next breath, she's talking about something completely different. I said, you were just talking about this. It has nothing to do with what you just mentioned. She goes, yeah, I know. I'm very distracted. Okay, next thing we want to talk about is, it's just I don't know, it's something you need to know. It's called, these were all the problems that we've done so far. They had a solution, right? They had one solution. They had one value for the variable that made the equation true. Okay? So when you're working through a problem and everything looks like it's going to work out okay, and you get an answer, and if you were to check your answer worked, that's one solution for a problem. You're going to run into problems, and let's write no solution. And then write the word identity. Now, you don't need to see long examples of this, okay? Here's what you need to see. You need to see that if you're working your way through a problem, okay, and let's say that you get down towards the end of the problem, and the end of the problem says that 9m minus 4 is equal to 9m plus 5. And sometimes what will happen is you don't really notice anything, and you just go, okay, I'm going to move the smaller. Well, they're the same. I'll just subtract 9 from each side. And I subtract 9m from each side. And when I do, I get negative 4 equals 5, don't I? Because both of the 9m's cancel out. You didn't do anything wrong, okay? It just means that there is not a solution for that problem. There's no value of the variable that will make it true. If you've got 9m and say 9m is 9, well, 9 minus 4 is never going to be equal to 9 plus 5, is it? Never going to happen. Okay? If you get down to that stage in a problem, before you write no solution, just glance back up at your work and make sure you didn't make a mistake in your work. And if everything looks right, then this is where you just stop and you put the symbol or the abbreviation no solution. There's not a solution that will satisfy that equation. The other type of problem that you will see is called an identity problem, and what it may look like at the end of the problem, or as you're narrowing the problem down, it might look like 4x plus 2 is equal to 4x plus 2. There's nothing you can do here, is there? If you subtract 4x from both sides, because you're just kind of doing what you've been trained to do, you get 2 equals 2. Well, yeah, 2 always equals 2. If you get to this step in a problem, it's just called an identity problem. And the answer is that it's an identity problem. What that means is that the left side of the equation, the left side of the equal sign at one time, is exactly the same as the right side of the equal sign. They share the same identity. All right? They're the same. So you can't come to a solution. But if it was a multiple choice quiz and you got down to here in your work, and answer choice A is that x equals 2, and answer choice B is no solution, answer choice C is identity, and answer choice D is x equals 0, you would choose identity. Okay? Problem on the left, where the left side will never equal the right side, that's a no solution. Problem on the right, where both sides are identical, that's an identity problem. Clear? All right. So we've gone through that, and it's time for me to give you some practice problems.